Have you ever wondered what it would feel like if something truly otherworldly was hurtling toward us from the depths of space? What if NASA itself admitted that this mysterious object defies everything we know about the universe? Imagine the chill running down your spine as experts scramble to uncover its secrets that could rewrite human history. Stick around, because what started as a distant blip on a telescope has escalated into a global obsession, and by the end of this, you'll be questioning everything you thought you knew about the stars above. Let's dive right in. What exactly is this enigma that's got the world's top minds on high alert? It's called 3I Atlas, an interstellar object first spotted racing through our solar system. But here's the hook. NASA's head has gone on record confirming it's not a natural formation like any comet or asteroid we've seen before, and now it's edging closer to Earth. Why the sudden panic? How did we even detect it? We'll break it all down, step by step, revealing the clues that have scientists losing sleep. It's July 2025, and in the remote observatories of Chile, a routine scan by the Atlas Survey telescope catches something anomalous streaking across the night sky. At first glance, who would think much of it? Astronomers initially pegged it as just another wandering space rock, what we call a comet or asteroid. But as data poured in, the what became clear. This wasn't from our neighborhood. It was barreling in from interstellar space, far beyond our solar system's edges. When did this all unfold? Right in the heat of summer, triggering an unprecedented scramble. Where did it originate? That's the million-dollar question. Deep space, possibly from another star system entirely. Why did it catch everyone's eye so quickly? Its speed was off the charts, clocking in at velocities no solar system object could match, and its trajectory was bizarre, slicing through at an angle that screamed, outsider. How did the global response kick off? Within days, word spread like wildfire among scientific circles. Who stepped up first? NASA's Planetary Defense Team, of course. They're the ones tasked with monitoring potential threats from space. In a move that shocked even seasoned experts, they bumped 3I Atlas straight to Level 5 alert, the highest classification possible. To put that in perspective, previous interstellar visitors like Oumuamua in 2017 and Borisov in 2019 never even came close to that rating. This wasn't just protocol, it was a red flag waving furiously. Why such urgency? The object's behavior didn't add up. Too fast, too steady, too alien. As curiosity built, observatories worldwide pivoted their lenses. Over 200 telescopes locked on within 2 weeks, marking one of the swiftest coordinated efforts in astronomical history. From the icy peaks of Chile to the clear skies of Hawaii, data flooded in. More than 4,000 position measurements from 227 sites across every continent. Who were the key players? Heavy hitters like the James Webb Space Telescope, Hubble, the Very Large Telescope, Spherex, Gemini South and Palomar Observatory all joined the hunt. What did they uncover? The object's light reflection was unnaturally high, its surface smooth and shiny, with an irregular shape that defied typical comet profiles. How was it moving? With a precision that suggested something more engineered than organic. But wait, here's where the mystery deepens, pulling you in further. As observations piled up, scientists compiled what they dubbed the anomaly scorecard, 5 red flags that screamed, this wasn't business as usual. First, its non-gravitational acceleration was minuscule, under 15 meters per day squared. Why is that odd? Normal comets get jostled by escaping gases, but this one held steady, implying a massive, dense core, perhaps 5 kilometers wide. How could something so heavy maintain such poise? It hinted at internal strength far beyond natural space debris. Second, the chemistry. A staggering 95% carbon dioxide and just 5% water, flipping the script on every known comet. Where could such a composition form? In the frigid voids of space, colder than anything in our system. Third, spectral analysis revealed nickel without iron, a separation that's rare in nature. On Earth, it requires industrial processes like the Mond method. How might this occur naturally? Perhaps through exotic reactions in carbon-rich environments, but it's a stretch that fuels wild speculation. Fourth, its path. a mere 5 degrees above the planetary plane, unlike Oumuamua's 33 degrees or Borisov's 44. Why so flat? It made tracking effortless, almost as if it wanted to be seen. And fifth, it started outgassing at 4.5 astronomical units from the Sun, way beyond Jupiter. What triggered it? That high CO2 content, creating a visible coma from the get-go. Each anomaly builds on the last, leaving you wondering, is this a cosmic accident or something deliberate? Hang on, because the real jaw-dropper came during a celestial event that lit up the skies. Fast forward to September 7th, 2025. When did the impossible happen? During a total lunar eclipse as the moon turned blood red. What unfolded? 3T Atlas erupted in a vivid green glow, so intense it was visible through backyard telescopes. Where was this spectacle seen? Across the globe, from urban rooftops to remote observatories. Photos and videos exploded online, captivating millions. But why green, and how without the usual culprit? Typically, cometary green comes from diatomic carbon, C2, reacting to sunlight. Yet, spectra showed almost no C2 or carbon chains. This green glow mystery baffled experts. One theory: layered surfaces trapping molecules set to release as it nears the sun, potentially intensifying the show. Another: rare fluorescent compounds unknown to our science. Whatever the how, it was mesmerizing, a beacon against the eclipse's darkness. Who witnessed it? Everyone from amateur stargazers to NASA's elite. Why does it matter? It shattered expectations, proving space still hides wonders that could upend our knowledge. But this was just the spark. Scientists weren't done probing. As 3I Atlas plunged deeper into the solar system, a battery of tests ensued. How were they conducted? Through international collaboration, the largest ever for one object. First, polarimetry, analyzing scattered light to gauge dust particles. What did it reveal? Unusually smooth reflective grains, not the gritty stuff around standard comets. Next, stellar occultation, timing a star's dimming as the object passed in front. Why useful? It nailed down size and shape, a rounded body kilometers across. Radio monitoring scanned for signals, none found, as expected for something natural. But the crown jewel? Spectroscopy, dissecting light to map chemistry. Early data echoed the green mystery, with more revelations pending. When will we know more? Key milestones loom: October 3rd, a close Mars flyby at 0.19 AU, where the Mars Reconnaissance Orbiter snaps high-res photos. Late October, perihelion at 1.36 AU, heating things up. November 3rd, Venus proximity. And March 16th, 2026, a Jupiter brush at 0.36 AU, possibly with NASA's Juno spacecraft swooping in. These tests crystallized 5 critical numbers, each a breadcrumb leading to the truth. What are they? First, speed, 68 km/s, hyperbolic orbit confirming interstellar origins. It's a one-way visitor. Why so fast? Untethered from our sun's pull. Second, perihelion, 1.36 AU, priming for outgassing without annihilation. How might it change? New vapors could alter its appearance dramatically. Third, size, 1 to 5 km wide, explaining its stability. Fourth, gas ratio, 95% CO2 to 5% water, shifting with solar distance, hinting at layered composition. Fifth, orbital tilt, just 5 degrees, optimizing observations. Together, these stats scream anomaly. But what do they imply for humanity? The answers could be game changers. If natural, 3I Atlas redefines galactic chemistry. Its CO2 dominance suggests birth in ultra-cold stellar disks, diversifying our view of cosmic diversity. Why care? It informs exoplanet habitability, tracing life's building blocks across stars. But if artificial, the implications explode. Scientists hunt for radio signals, specular glints from metallic surfaces, unnatural thrust or isotopic oddities. Who knows what proof might emerge? A single flash could confirm extraterrestrial tech, shattering isolation. To grasp the hype, consider history. What came before? Oumuamua in 2017, late detected, cigar-shaped with unexplained acceleration, gone before full scrutiny. Borisov in 2019, a textbook comet reassuringly normal. Now 3I Atlas, Early catch anomalies galore global watch. How does it differ? Depth of study. It's not slipping away unanswered. This saga preps us for tomorrow. How? The Rubin Observatory in Chile will spot dozens yearly with its sky-sweeping camera. Rapid intercept probes, 200-300 kg craft for close-ups, are in planning. Protocols for coordination ensure smoother responses. Why vital? They double as asteroid defenses, safeguarding Earth. Yet, mysteries linger, keeping you hooked. What size is its nucleus exactly? Mars imaging will tell. Will new gases emerge at perihelion? An iron signature, Juno intercept, long-term path. Each unresolved thread pulls you deeper into the unknown. As 3I Atlas nears, the universe feels alive with possibility. Is it a harbinger of wonders or warnings? One thing's certain, the skies hold more secrets than we can imagine. What will the next revelation bring? Keep watching, the story's far from over. As 3I Atlas speeds closer to Earth, one thing is clear. The universe still holds secrets far beyond our understanding. Whether this object is a natural wanderer or something far more mysterious, it's rewriting everything we thought we knew about the cosmos. Could it be the key to unlocking the truth about life beyond our solar system, or a warning from the stars themselves? Only time will tell. What do you think? Let us know your theories in the comments, and don't forget to like, share, and subscribe for more deep space mysteries. The story of 3I Atlas has only just begun.